Hi there, my name is Andrew Hashker, and I look after application modernization for Google Cloud across Asia Pacific. I'm based in Sydney, in Australia, and I'm joined by our esteemed partner, Robin, and Ankur Desai will be presenting on Database as a Service, following on from my overview of Google Anthos in the first part of this session. So if we want to think about the context for where this session is aimed at, what we're really looking at is a volume of customers that I'm engaging with all across Asia Pacific that are running workloads in data centers today. But they are looking to bridge to multi-cloud and maybe employ a hybrid cloud strategy. There's still a very strong focus around accelerating the adoption of containerized applications, not just lift and shift, picking up a virtual machine with Windows and Linux and moving into cloud, but potentially modernizing and optimizing as we take that approach. But I guess still, the largest majority of workloads we're seeing are driven by on-premises virtual machine data center-oriented workloads. So these are some of the problems that we're trying to solve for our customers. Now, if we think about application modernization, often these themes are driven by open source technologies like Kubernetes and Istio and Tekton for build and Knative for serverless. But I like to simplify the approach in terms of 4 key areas that we see adding value to businesses. And that may start in terms of modernizing the application architecture that underpins revenue generating apps, moving away from monolithic architectures to microservices, maybe moving away from physical servers and virtual machines to containers and clouds, and then taking the software delivery approach and modernizing it further, implementing DevOps and CI/CD beyond more traditional waterfall software delivery approaches. And the last one there around taking proprietary applications, proprietary operating systems, applications, hardware appliances that may exist, and moving those to open source where possible. Seems to be a theme in many organizations' strategy documents today. So if we think about how we're doing this, we've considered the first generation of cloud native, typically driving towards infrastructure automation and continuous delivery, continuous deployment historically. Lots of focus on infrastructure as code and configuration management and virtualization, maybe applications on CD pipelines. But really, what we should be focusing on for the second generation of cloud native is all about applications. And it's all about sustainable scale. So if we think about sustainable scale and this second generation of cloud native, we're noticing themes around virtualized namespaces, configuration as data, Kubernetes resource management, not only for Kubernetes-based workloads, but all of the workloads that we may want to manage at scale. And event-driven architectures, so being able to deliver and scale our platforms and our applications based on consumer-driven demand. We're also integrating migration factories into the approach and automation in transforming and modernizing and optimizing those workloads, in addition to serving SRE-based practices to all IT teams and all parts of the business. So a couple of problems are emerging in the market that we see, and the adoption of open source technologies is a great initiative, but management of these technologies isn't particularly easy at scale. I've noticed an organization that I was working with in India hired 30 people just to go and manage their Istio service mesh. It shouldn't have to be that hard hiring huge volumes of teams just to go and manage the platform. We're also seeing that in a developer-led value proposition, maintaining that consistent security posture is potentially quite difficult to do. And maintaining consistent security across applications and infrastructure is becoming increasingly more and more difficult, especially with the dynamic change that we're noticing with applications. So we're spending a lot more time managing and configuring infrastructure rather than focusing on the applications. So if we think about how Google is solving for some of these problems, with Anthos and many other technologies in the ecosystem, we like to start by analyzing the current state and evaluating API maturity, maybe with Apigee Compass, cultural sensitivities and current state with DORA, the DevOps Research and Assessment Organization, being able to understand the capabilities that maybe you deliver well and some that may require a bit of improvement. And then being able to evaluate the workloads as well. What Windows and Linux virtual machines do we have, and what is their propensity to being able to containerize those in an automated way. So whether we're migrating those and leveraging automated migration tool sets like Migrate for Anthos or G4, which will convert legacy code into modern languages, or whether it's building new applications and using Cloud Code for libraries of code, being able to extend into the build ecosystem of Cloud Build, maybe Firebase and AppSheet for no code, and then choosing your platform of choice, whether it's Cloud Run as a serverless framework built on Knative, or whether it's Functions, App Engine, or Google Kubernetes Engine, which underpins the container orchestration layer for Anthos. Now, I guess integrating data operations, observability, logging, monitoring, application performance management is going to be key to operating these platforms and serving these applications well. And all of that is fully integrated into the portfolio. Now, I guess from an internal infrastructure perspective, we've spoken about a number of different tools that help make managing these modern application stacks easy. But if we think about connecting that to a consumer, a web-enabled device, an IoT sensor, typically we're going to need to have an API-driven approach and an API developer-centric portal to go and connect that infrastructure and that platform to those consumers, and that's where Apigee comes in. So if you think about the history of innovation around modern applications with a Google lens on it, in 2003, around 4 Google engineers worked to automate cluster management for the workloads that we were hosting in our clouds. If we consider what that looks like to date, we are scheduling several billion containers per week. And that was last year, ever expanding, I guess, as we grow. And what we chose to do around 2015 was create a platform that was more accessible to all organizations to leverage the same innovation. So in July of 2015, we released an open source Kubernetes 1.0, and following on from there, we had Google Kubernetes Engine generally available to the public. Now we extended Kubernetes Engine to Istio as an open source, and then managed service mesh with Anthos Service Mesh, serverless with Knative, and then Cloud Run, to what you know about Anthos today, which we'll cover off further throughout this presentation. Now, if we think about where workloads are being hosted, and I guess this is a key theme with a lot of organizations deploying historically servers that would take months to go and procure and build and then maintain ongoing, through to virtualization and virtual machines, which could typically be deployed in a couple of mouse clicks or deployed in minutes, through to containers, more recently over the last few years, being able to deploy and run in seconds. We're noticing that serverless is probably one of the technologies that is driving a lot more innovation in the market for new workloads too. Being able to scale with those event-driven architectures, being able to run a platform that is application and developer-centric without having to manage that underlying fabric, that underlying Kubernetes platform in the same way. Now, I guess the benefit of both containers and Kubernetes and serverless technologies with Anthos is it runs on top of the same stack, and it is portable across wherever Anthos can run. So if we think about where Anthos can run, obviously Google Cloud is the primary choice for many organizations considering to run application modernization in a new cloud. However, we do also support AWS and Azure going generally available very soon, in addition to vSphere for on-premises and data centers, bare metal servers with Ubuntu, CentOS, Red Hat Enterprise Linux, OpenStack, and maybe attached clusters where you might want to go and manage another conformant version of Kubernetes. Maybe it's EKS or AKS or OpenShift. All of these things are essentially centrally managed through Anthos with many of the features that you see in the blue box above it. So beyond just managing Kubernetes clusters, we've got a managed service mesh that allows you to connect all of those microservices and enforce security and provide visibility and observability across all of those microservices. We automate policy management with Anthos configuration management, and I've been working with a large financial organization recently that uses Anthos configuration management to scale configuration across all of their clusters. You can leverage Anthos Connect Gateway to, I guess, productionize and make the Kubernetes API more enterprise friendly. Day 2 operations around logging and monitoring and application performance management helps you serve your business objectives and SLA well. And centralizing all of these views through the same management console, same single pane of glass view, is what we offer with Anthos. Now, lastly, on the development space, we have build capabilities that allow you to start your CI/CD journey with Cloud Build, integrated AI with hybrid AI that can run anywhere that Anthos can run, and then Cloud Run, which is serverless with that portability to go and run across any of those endpoints. So ultimately, the main focus here is whether you're running a modern container-based application or whether you're modernizing or managing a legacy VM or physical-based application, or whether you're deploying a modern application to replace a proprietary application from the marketplace. All of those can be managed centrally through Anthos, connected to your consumer with Apigee, but essentially deployed across Google Cloud, multi-cloud, and hybrid and edge. So we do have reference architectures on top of many OEMs in the market, whether it's HPE or Cisco or Dell, Lenovo, and they're all available on our platform partners portion of our site. So if I think about Kubernetes, I guess what we're considering here is the ability to scale a modern applications fabric, like Kubernetes with production support, enterprise scale, and we've got record-breaking 15,000 node scalability for a single cluster with GKE. We support GPU and TPU integration for hardware accelerators and dozens of unique security features, which we can touch on as we go through. So the main value here is that we're saving a lot of that effort for managing workloads at scale. And we provide AI-driven auto scaling and repair and auto upgrades to keep all of those clusters healthy and reduce the amount of management effort to go and do that manually. We also centralize the view across a unified management hub so we can orchestrate and manage the on-prem Kubernetes workloads in addition to those that run in the cloud through the same UI, which means you've got a consistent operating model between GCP and on-prem. We can also, as I mentioned with declarative config, set your policy from the one manifest. Put all of your configuration, security, compliance, policy elements into that one YAML and deploy it across all of your Kubernetes clusters through Anthos configuration management. So you're pulling down that policy from a central source repository, GitOps-based approach to provide policy and configuration in a declarative way. And if anything changes, we can instantly revert back to how that policy had defined the environment to be, or even prevent any changes from happening in that environment in the first place. Now, if you think about zero trust networking, security is a primary focus for many organizations that we talk to. And I guess one of the things that makes a microservices environment secure is a managed service mesh. So based on open source Istio, Anthos Service Mesh gives you that management and single pane of glass view for encrypting traffic through MTLS between all of the microservices. It gives you a service identity. It allows you to monitor your service level objectives for each of your microservices. And it will give you those AI-driven insights, recommendations, and operations analytics to ensure that the environment connects and works smoothly. Now, on operations, if we consider the many aspects to maintaining an SLA, understanding which metrics to monitor is one of the key aspects to organization initiatives today. But I guess being able to find that root cause analysis quickly with an application performance monitoring platform is key to reduce your mean time to restore if you have any failures or outages. Centralizing your logs allows you to ensure that you've got good visibility across the environment, and you can potentially isolate an issue before it causes an outage. Now, if you think about AI and being able to have AI that is made easy for enterprises, we have a hybrid AI platform with Anthos that essentially allows you to deploy one-click deployment models of pre-trained AI models created by a team of Google PhDs. So you can go and deploy that into any Anthos environment via the Anthos Marketplace, and it gives you that full MLOps lifecycle management available in any location that Anthos supports. Now, speaking of the marketplace, this one-click ecosystem with the Anthos Marketplace allows you to click to deploy any pre-integrated Kubernetes applications anywhere that Anthos runs. So the value to this, and what I'm seeing with organizations all across Asia Pacific, is replacing proprietary software with a marketplace item means that you get centralized billing, you get integrated support, and you know that that application has been validated to run on the platform. And it's an easy choice to go and replace the application and potentially do a data migration to go and support it. Now, in terms of serverless and containers at scale, we've spoken briefly around the value of serverless, but we've got many different flavors of serverless and container platforms which you may choose to deploy your modern application onto. So for application or App Engine, essentially you can bring your code and we'll manage the rest. So we are serving as your SRE to go and manage the underlying platform. All you need to do is bring the code that you want to run and away you go. Whereas Kubernetes Engine is a little bit more customizable. You get to bring your containerized app and manage the fabric in a way that makes sense for your business. Whereas I guess something like Cloud Run allows you to still bring that containerized image, but essentially that Cloud Run Knative based fabric is elevating the platform. So you don't need to do as much maintenance on the underlying Kubernetes Engine platform there. Now, lastly, functions. We're noticing that organizations are very keen at the moment for new deployed modern apps to deploy serverless first, maybe have event-driven architectures, run on Google infrastructure, and essentially take the pressure off managing the platform. Now, I guess this is truly where cloud was meant to be for many organizations. So we're seeing this scale for many new application initiatives. It may not suit all applications, which is why we've got the flexibility of some of the other platforms that we've spoken about. Now, on CI/CD and being able to deliver software effectively, there are many different stages that we may move through from source to build, test, artifact storage, deployment, and then day two operations. And I was speaking to an organization in the healthcare sector recently that said they've got 30 loosely coupled open source tool sets as part of their CI/CD pipeline, and it was very complex to manage. There were so many different third-party tools, and if anything went wrong, there was no centralized single point of contact for support. So at Google, we try and simplify this view and essentially build all of the ecosystem into one perspective and one view, one portfolio that you can come to for your end-to-end support. So automating and extending the ecosystem from source through cloud source repositories, through the build test with cloud build, artifact storage on container registry, and cloud storage, and then deployment with Spinnaker, with many other options coming in the imminent future. So if I think about what an organization might need to consider in building some of these new apps or modernizing the apps that they have with a focus on risk mitigation. I would say that security is probably the primary focus for a lot of organizations in building and modernizing apps. And there are many different things that you might want to consider. I'd propose, though, that we could go and evaluate all of these aspects and see where are the quick wins. What have we done on the infrastructural workload side? Do we have a container optimized operating system? Do we have disk encryption? Do we have a node auto upgrade enabled? Are we attesting the container images with binary authorization so that we know that the software we're running has been attested and validated by the organization. Do we have VPC flow logs and security analytics and a managed service mesh on the network side? Do we have vulnerability scanning for applications and denial of service protection and web security scanning on the application front? And then from an identity perspective, have we centralized identity management? Do we have a managed certificate authority? And do we have context-aware access? And then I guess lastly on the configuration policy front, I did talk about one organization that liked to manage their configuration and policy at scale, but there are many different aspects there around validating config, having health analytics for security, being able to have next generation labels and generalized admission policy to manage your security, your compliance, and your configuration centrally. So all of these typically recommendations that we could go through, find some quick wins, and help you identify what we could go and implement easily without too much impact on the business. Now, in terms of use cases, I'm seeing organizations with a focus on low latency services looking to deploy at the edge, or maybe on premises closer to their consumers. Whereas organizations that maybe want to release software faster to market might be looking at a use case for canary clusters, where they could implement their managed service mesh or maybe an API management platform to go and provide the different customers and consumers of different versions of their applications as they need. So if they're rolling out a new 1.1 version of software, they could roll out that canary to 5% of their customers and gradually scale that to 10%, 15%, 50%, and eventually decommission their original application. So we're seeing some newer use cases like that proliferate across the market, in addition to maybe environment separation across different teams, different organizations, different revenue streams, maybe deploying one type of workload on one cloud, another type on-prem, and a third maybe on their production-grade cloud. Now, having the same centralized management view makes sense, when you're trying to manage policy and security and configuration identity at scale. But the choice of cloud and the choice of endpoint should be flexible based on what the application needs. So just to summarize some of the key things that we talked about here, essentially what we're offering with Anthos as part of this platform is simplified management and consistent controls. We're giving portability and flexibility to the applications that you're choosing to modernize or build, and we're giving you that extensibility through the marketplace to go and replace proprietary applications with open source or supported components from the ISV ecosystem. Now, if you'd like to go and evaluate where your organization is at with regards to your DevOps or cloud native journey, there's a quick check that you can run. Go to cloud.google.com/DevOps and take the quick check. There are just a couple of questions there, 4 questions that will help you evaluate some key things, some key capabilities that you can improve. And depending upon your answer for some of the metrics that we've got there, you may be rating at the lower end of the spectrum, or maybe you're performing quite well and operating at the elite end of the spectrum. But the main story here is that I guess there are always areas that we can improve. Maybe your focus on version control or trunk-based development or CI/CD or test automation is not as strong as what the industry-leading best practice could be. And maybe you might like to take that one step further and compare your results to other results within your industry or segment. And we can extend that further with a full assessment of DORA and DevOps beyond what you might experience with a quick check. So do reach out if that's something you'd like to explore as well. Now, just an example on TCO and ROI. I often get asked by executives, why is it imperative for us to modernize applications? Why can't we just go and leave our applications running on virtual machines to date? Surely we're not going to be losing any revenue or losing any of our investment as a result of that. But what we can see is typically by modernizing and reducing the footprint of what we need to go and run our key applications and giving them that portability and flexibility and scalability and security, there are many benefits that do accelerate the way that we go and take these applications to market. And we can also see that if we delay the modernization activity, even by a quarter, there is a monetary impact associated with that. So by not going forward and modernizing some of the quick win applications that we have, then maybe the detriment to the business could be well represented in a model like this. So we can definitely go and run through that to show back to your leadership team and executives, I guess, the benefit in modernizing on the portfolio. Now, a couple of last questions that we get around being able to take the next steps. Maybe the experience of running cloud-native technologies is not particularly strong within your organization. I would say that that's where we try to make it easy with tools like Migrate for Anthos, where we automate the migration from your traditional Windows and Linux virtual machines through to Anthos Google Kubernetes Engine. So we've got a very low friction path to creating those artifacts and container images, YAML manifests as part of a wizard-driven approach, so that you can go and extract those applications out of those operating systems and run them portably on Kubernetes in an automated way. Now, I guess one last point is beyond infrastructure and beyond the platform, sometimes we're running legacy code within the customers and the data centers that I've seen. I've worked with organizations running legacy COBOL applications, maybe assembly or RPG for an ERP system, and being able to modernize those languages to something like Java allows you to make it a little bit more portable and maybe run that application on top of Kubernetes. So what I would suggest is we could analyze that legacy code, maybe give you the view on what it would take to go and port that over to a language like Java, run it on top of Kubernetes, and automate a lot of that development effort that may be constraining the organization for those apps. So in terms of the architecture, just logically, I guess being able to deploy on-prem in addition to connected console is what we see with service mesh spanning across both sites, centralized Kubernetes engine, and being able to have configuration management available across both on-prem and in the cloud. Anthos, as we mentioned, runs on top of bare metal. Now, the main difference that we see is that on top of a vSphere environment, Google would manage, I guess, the underpinning Ubuntu operating system component that helps run the solution. Whereas on a bare metal solution with a Red Hat or a CentOS or Ubuntu operating system, that would largely be managed by either yourselves as a Google customer or a partner. And just to close out the differences there, some of the main things that we'll see in terms of persistent application storage. Obviously, we get that through vSphere-based data stores if we're running on top of vSphere. But if you're running on a bare metal operating system, this is clearly where we need a third-party storage solution heavily and tightly integrated within the platform. And I guess that's one of the aspects that Robin will touch on in the next part of this session. So to close out, in terms of some of the value we see, being able to improve the return on investment in modernizing applications, increasing the speed to which we can go and update applications and take them to our consumers, and reducing our non-coding activities are some of the main advantages that we see. But we can customize this to your environment and the scope that you're looking at for your initiatives. And the last one here, if you'd like to get started, very happy to run an application assessment workshop, come and analyze some of those things that you're running and provide you with a view on how we can get started and improve, in addition to the TCO and ROI report that will show you the benefits of modernizing your applications. For further reading, please go and review the cloud.google.com/Anthos, Apigee, or DevOps links that you see below, in addition to the Forrester's TEI report that we've hosted on our site. So I'll pause there, and it's time for Ankur to share on how Robin is tying into this story.
Thank you, Andrew. Let me quickly start presenting my screen. Okay. You can see my screen in full screen mode, right?
Yeah.
Okay. Thank you, Andrew. Hey, this is Ankur Desai from Robin.io. I'm the director of product here at Robin. I manage the product roadmap and go-to-market strategy for our enterprise product. And today we're going to talk about, uh, you know, how to deliver database as a service experience on top of Anthos, right? We'll start with why you would want to do that first, right? But we'll walk through what are the requirements, who needs to get involved, and what are the benefits of actually delivering a complete self-service database as a service experience for your developers, right? So let's start with why. Um, the modern DevOps philosophy, right? It kind of expects modern businesses to deliver products and new features faster, right? So typically, some product teams have a 2-week release cycle. Now that actually has implications for databases, right? Because databases are a key part of the overall deployment. So how do you make sure that the databases, which is what we call the stateful applications, actually keep up with your stateless applications in terms of how fast you can deliver updates to them? Right. So to make sure that your developers can deliver on their expected release cycles, you have to make sure the databases are also modernized in certain way. Right? Um, for a while, there was this philosophy that containerization and Kubernetes, all of it is meant for stateless applications like Nginx, right? Your web servers, your application logic. Do not touch your stateful applications like databases and data stores. Keep them on the side and only modernize the stateless part. But that won't cut it in the long run, right? So developers, they actually need to provision databases faster, and also they need to perform dev test refreshes faster, right? QA needs to be able to quickly create replicas of dev and production environments to quickly test and release new features, right? Ops teams need to accommodate high frequency provisioning, which is, because there are going to be multiple requests. So how do not become a bottleneck for your developers, right? And then IT needs to keep costs under control. If there are hundreds of database deployments running and you don't have control over it naturally, then you would incur a lot of cost. Now, keeping all of these requirements in mind, the old school model of delivering databases does not keep up, right? So if you look at the traditional way of provisioning databases, especially in the old SQL databases kind of environment, there is a kind of a workflow that goes from the developer requesting the database, and somebody approves it, and somebody requests hardware, somebody allocates storage, and there is a whole chain of events that typically takes a few weeks in some cases. But that doesn't work because in the modern DevOps world, within a couple of weeks, you actually have to release the product. Right? So if it takes 4 weeks to provision the database, you're not going to meet your release cycle. So now that is a big problem. So how do we go, about solving this problem? The first thing we need to think about is how do we make sure that the whole complexity and the workflows around approvals, all of them are basically taken out of the equation, and the developer now has a simple self-service experience, right? Without losing the control over who gets to deploy what and what is the cost of deploying a database. All of those things still have to be considered, but we still want to make sure that the developer, whenever they need a database, they can quickly deploy it. Right? And you see that database as a service, it's not exactly a completely new concept. In the cloud environments, you see, in GCP, you have Google Cloud SQL, right, where you can easily deploy a Postgres database and you can easily manage a Postgres database. You don't even have to become a database expert. Most of the complex operations are already automated, right? And it's a simple API or a UI command that can actually, do most of the database management activities for you. Now, how do you bring the same kind of simplicity on-prem with Anthos, right? And how do you make it universal enough to actually extend it to many databases and data stores, right? So you could say that I want to run DataStax Cassandra or Confluent Kafka as a service on my Anthos deployment. For that to happen, there are certain requirements, right? There are requirements on the two sides of the equation. So one is the platform engineering team that will deploy Anthos and manage Anthos. And then there is the development team, right, which is developers, data scientists, DBAs. These are the people who are the end users and they want to deploy certain applications like databases, right, or AI/ML applications. So between these two teams, there has to be a balance, right? So the platform engineering team, they want to standardize platform, right? So if Anthos is chosen to be the standard platform, for on-prem deployments, then they wouldn't like to actually introduce new platforms for databases, right? So it shouldn't be, okay, if databases are done in a different way, let's do them on a different virtualized environment, right? That is not an ideal scenario. But at the same time, they also want to provide a complete self-service solution, right? Because as the usage grows, if the developers are overly dependent on the platform engineering team, that basically means that it slows down the whole deployment and management process, and then platform team becomes the bottleneck, right? So they do want to actually create a service, a solution which enables the end users to manage most of the tasks themselves. At the same time, they want to maintain visibility and control over application infrastructure, right? And have a multi-tenant environment where they can consolidate multiple workloads, right, to improve hardware utilization. And now when you consolidate multiple workloads, you also have to make sure that you enforce separation of concerns, right? You enforce that a given team can only access this much hardware and their data is always secure, even within the same organization, within different teams. It is managed in a certain way that only the right people get access to the data, role-based access control policies, all of that, right? So Anthos actually helps with a lot of these things, right? Achieving multi-cloud portability. What Robin brings to the table is the additional automation to make the database as a service solution simple enough for the end user, right? So what do the end users, like developers, care about? They want to provision databases with ease, right? It should be a single API command or a single click on the UI that will actually deploy a database in the configuration a developer wants, right? So that's how easy it should be. At the same time, they want to meet application SLAs. So the database deployments have to be resilient. They have to be performant. They want to experiment really fast, right? Because if they're building a new feature, if they're building a new AI application, they want to make sure that they can experiment quickly, but at the same time create snapshots, right? Create point-in-time markers where if something goes wrong, I can easily go back to that point in time. How do they quickly restore applications? So if something fails, a server fails or a node goes down, how do they quickly dip into a backup repository and bring the application back, right? How do they manage the self-service? Manage the dev test refreshes in a self-service way, right? If I want to create a copy of a production database, I should not need to create a ticket for my IT team, right? I should be able to easily do it myself. And then how do I migrate application across hybrid and multi-cloud environments, right? So all of these things, if you look at it from the end user's perspective, they really want that simplicity, right? And the platform engineering team actually, they manage the platform and the infrastructure, but they also want to give this simplicity to the end users. And this is where Robin comes into it. So Robin Cloud Native Storage is a certified storage solution for Google Anthos as well as for GKE that sits on top of Anthos and GKE, right? That could be Anthos for bare metal or on virtual machines, so that's your on-prem infrastructure, or GKE in GCP. Right? So it doesn't really matter what your underlying form of infrastructure is. And then Robin Cloud Native Storage creates this hybrid cloud storage and data management solution on top of it that provides the necessary simplicity, the necessary automation, and we'll talk about what that means in a while, to run any stateful application, including your RDBMS applications like SQL Server or NoSQL applications like MongoDB, Cassandra, queues like Kafka, right, Prometheus, time series databases, or big data applications like your AI/ML workloads, including Spark. So for these applications, right, Robin provides a simple automated way of deploying and managing these applications on Anthos. And that makes life easier for the developers, data scientists, and DBAs who can now provision applications and manage the applications in a self-service manner using Robin Storage Class. So before we proceed, I just want to actually give you a social proof point of Robin Cloud Native Storage being the leading storage and data management solution for Kubernetes. Right? So GigaOM has featured us as a leader and a performer for Kubernetes storage as well as Kubernetes data protection. IDC has named us an innovator in the containerized storage platform space, and Gartner has covered Robin in a lot of foundational research notes, right? And then we also have multiple Fortune 500 customers that are deploying stateful applications on Kubernetes on petabyte scale. Customers like BNP Paribas, Credit Suisse, SAP, Rakuten, Palo Alto Networks. All of these customers use Robin to manage stateful applications on Kubernetes. So now let's talk about a few key challenges when it comes to managing stateful workloads on Kubernetes. Right? You might ask the question, okay, with Kubernetes, there is a default storage class. Maybe I can deploy Cassandra using the default storage class. So why do I need something in addition to that? Why do I need a cloud native storage solution when there is a CSI layer available with Kubernetes, and I can deploy a stateful application already without any additional layers in it? So there are a few things, right, that you need to take care of when you deploy applications, stateful applications on Anthos and on Kubernetes. Right, so one thing, the first and foremost, is data has to always be available, even if a pod or a disk fails, right? So you need to have a resilient replication mechanism that understands how an application is deployed in the context of Kubernetes and Anthos, and make sure that data is replicated in such a way that even if a disk goes down, the pod and the application does not actually see any service disruption. The second key point is that in the DevOps world, the developers are now deploying and managing databases, right? So they are not necessarily storage experts. So how do we make sure we automate the complex storage processes or operations, and we make sure we make it simple enough for the developers to manage the databases themselves? Third key factor is predictable app performance, right? So if there are multiple applications running on the same Anthos cluster, how do we make sure that across the different applications we maintain performance predictability? So if, let's say, if there is a Cassandra application running and it runs a massive query, with a joint operation, you want to make sure that the IOPS given to that application is limited so that it does not bring down other applications with it. Right? And then the fourth key point is, how do you quickly snapshot, clone, backup? So all of these data management tasks that were typically driven by the storage teams in the past, how do you make sure that they are easy enough, once again, to be performed by the developers, and we make sure that we provide the required business continuity for stateful applications. And the fifth key point is, how do you bring observability beyond what Anthos already provides? So the Anthos has a very strong solution for observability, including metrics monitoring and dashboards, everything. But on top of that, specifically for stateful workloads, right? How do you make sure if, let's say, a disk goes down, how do you make sure that how you quickly establish how many applications are at risk, or how many applications can be impacted because of that disk, going down, how many persistent volumes are at rest, right? So all of these things, it's a little bit of addition on top of what Anthos already provides. So these are the day zero capabilities you would need when you're running stateful applications, right? So first thing, you need a cloud native storage solution, and we discussed why there is a requirement for that. So Robin CNS is a lightweight operator, and it installs on Anthos within 5 minutes, right? It will discover all the local disks available to it, and if you're running in the cloud, we will discover all the cloud disks attached to your cluster, and we'll make sure that we will pool all the resources together to quickly create a storage solution for you, right? That can serve block and file storage. The second key capability is high availability. Right? We want to make sure that when you deploy your application, it is always available. Right? So we provide strictly consistent replication and auto resync on fall behind. We also make sure if there is a if the primary replica fails, we'll make sure that the failover is fast enough to avoid split run scenario. And the pod that is relying on the persistent volume does not experience any service disruption. And the third key capability needed on day zero is advanced placement, right? So how do you make sure, for your stateful workloads, you enforce data locality, where compute and storage essentially comes from the same host, or things like, anti-affinity across workloads, right? Or across different components of the same workload. So you should be able to see when you're deploying, let's say, a MongoDB cluster, right? You should be able to say, my MongoDB has 5 shards, and for a given shard, I need 3-way replication, but no replica should reside on the same rack, right? So even if a rack goes down, I want to make sure that my application is running. So this has to be actually made available to the developers in a simple enough form where they can easily define these placement policies and enforce them on Anthos. And then as you deploy your applications, right? So for stateful applications, these are long-running mission-critical applications. On day zero, you actually, let's say, deploy it with all of the necessary requirements. But as you keep running these applications, there are always going to be more requirements, right? So one is performance. How do you make sure that we keep the performance over the long period of time? And to begin with, it is you want to make sure that your storage solution is highly performant, right? So Robin, in the cloud native storage space, we have seen Robin is usually faster, up to 2x faster than our closest competition. And then we have smart features like cloud data rebalancing and capping IOPS to make sure that we manage the performance in such a way that we can maintain it in a predictable manner in the long run. There is capacity management. So Robin allows you to quickly add and remove capacity to your Anthos cluster and make it a part of the overall storage pool capacity, right? And as on an application basis, as your volumes grow, you can easily grow or shrink the volume size with Robin. Then there is observability, where we talked about how do you map storage allocations from the application to nodes to disk and get detailed storage metrics, as well as when something fails, how do you quickly troubleshoot for root cause analysis, and how do you quickly find the blast radius to determine what needs to be looked at. Right? So Robin will provide a tool called Sherlock that can, within a few milliseconds, it will get you the required information to actually take the necessary action. And the fourth key capability on an ongoing basis is data management. How do you quickly snapshot or roll back your applications, right? Because stateful applications in the context of Kubernetes have multiple components. So we want to make sure that we can snapshot, we can back up, or we can port applications across different clusters in such a way that it is simple enough to do, but at the same time, it is application consistent, and it is with a single command we can actually do these operations. So this is where Robin actually brings the application awareness perspective on Anthos. Right. So what this means is when you deploy, let's say, a MySQL database on Anthos, it is more than just the storage volume, right? It's more than the data that is stored in the storage volume. So there is data which is stored in the persistent volume claims, but there is also configuration and metadata information, right? So all of these things combined actually make an application. So when you want to ensure data consistency on an application level, you want to make sure that you take all of these components into consideration and then perform operations on all of these components at the same time. Right. So data management for applications must be really easy for developers, and it should be like a single command to do any sort of data management. And that actually involves a lot of automation. Right? How do you make sure that when somebody says, I want to back up MySQL, right? So all of the things that need to happen are taken care of, right? That's where Robin actually brings the application perspective, where you can register any application with Robin, right? And then Robin will auto-discover the application's data, metadata, and configuration, and will wrap all of these components in a single entity. So now you can say this single entity, I want to back up this single entity, or I want to snapshot this single entity. And this becomes really easy for the developers now to do it on a day-to-day basis, or even make it a part of a CI/CD pipeline, right? Because now it's a automated single command that can easily be fired when needed. Here is an example of what we mean when we say we have automated things, right? So think about when you want to create a snapshot of your application, right? Now the snapshot can be very useful to recover from user errors, or actually intentional user experimentation, right? So you could say, I want a point-in-time snapshot because I know right now my application is in stable state. So I want to now experiment on it, right? I might do some errors, or I want to upgrade my application, so the upgrade might fail. So at that time, I would like to quickly recover from the failure, right? And that's where snapshot can actually give you that ability to roll back your applications quickly to a point in time. Now with Robin, creating snapshot is really, really simple, right? So you say kubectl Robin, you snapshot, and then you give the application name that you want to snapshot and the snapshot name. And at that point, Robin will capture the application's data, configuration, and metadata, and it will create an application and crash consistent snapshot, right? The snapshot is very fast. It's very, very quick, because this is based on redirect on write technology. So we are not actually creating a copy of the data every time you create a snapshot. We're basically creating pointers, and we are capturing the metadata to make sure we understand what are the blocks, the storage blocks that are a part of a particular snapshot. And as a result of that, because we are not copying data multiple times over, the snapshotting mechanism with Robin is also very space efficient, right? So it is very storage efficient. So given all of these benefits, right, what it gives you is basically a cost efficient solution that is very, very fast and very easy to use. Right, a developer can now create as many snapshots they want, because it's really easy to create, and it's not going to cost any massive incremental cost, because it is based on redirect on write technology. Now snapshots are really useful when you have user errors that need to be recovered from. But what if there are system failures, right? If your node fails, or if your data center goes down. In that event, you want to have an offsite backup that can easily be restored, right? So what we do is basically using the snapshot, we can actually create a backup. And this backup is basically, it's actually a full copy of your data, right? So the first backup is full copy of your data, and then onwards you can take incremental backups. So here it is very useful to have a backup if your disk fails or the server fails. So it's from recovering from hardware failures, right? It is very useful also for disaster recovery scenarios, or for meeting compliance requirements, right? Where you want to actually keep, backups at different points in time, So you can actually, for compliance audit, you can go back and pull a backup and show the application state at that point in time. So backing up application, once again, is very, very easy with Robin. It's a single command, Robin backup, and you give the snapshot name and repository name, and we'll quickly back up that application for you. Right. So this is, once again, it's forever incremental, and it's RBAC enabled to make sure that once the backup is in the cloud, only the authorized users can access the backup. Then third key data management aspect is cloning and copy data management. Now, this is critical when you have multiple teams that need to work together to deliver new feature, and as a result of that, right, they might want to create different copies of the database. So imagine a scenario where you want to create a dev test refresh, where the QA team as well as the dev team needs a fresh copy of the production database. So here, once again, Robin actually makes it very, very simple, right? So first you take a snapshot, and then with a single clone command, we create an exact replica of the database, right? And these are independent replicas that can be worked on independently. But at the same time, they are based on thin cloning technology. So these are, once again, very quick to create and very storage efficient. Right? So the key use cases here are basically you are, running database report or analytics on your production database without impacting the performance of the production database, or you want to actually test an upgrade or a patch before you apply it to your production database, right? So here, once again, for your stateful applications, this is very useful to create clones and experiment and try different things before you actually apply them to your production environments. And then last but not the least, right, I think Andrew mentioned how you can create a hybrid cloud environment with Anthos and GCP and GKE in the cloud, right? So Anthos actually makes it really, really easy to create these environments and have a consistent user experience with a similar or the same marketplace as well as the console that you would use on GCP. You can see the same thing on Anthos. What Robin brings in addition is basically the consistency of managing stateful applications on these different environments and the ability to move these applications easily, right? Because as we saw, it's not just the data that needs to be moved. When you're running a Kafka application or you're running MySQL, right? And if you want to take it from Anthos on-prem to GKE, there are certain aspects that need to be taken care of, right? And that's where Robin actually makes it really simple. With Robin, with running Robin as the storage solution on Anthos, as well as, maybe in the cloud on GKE or in your edge data centers with Anthos bare metal, you can easily take a snapshot of your existing application, push it to the Cloud Object Store, which is GCS, and then from there, anybody who has access to that backup repository can then actually take it to the new cluster, right? So where they can just simply say, I want to pull this application from the backup repository and I want to put it on GKE or Anthos on Edge. Right? That actually makes it really, really easy to move applications across different environments on different clusters. And with that, I would, like to wrap up the presentation. I would, encourage you to try Robin, because we have a free for life edition available, Robin Express, that you can find on git.robin.io, and documentation is also available at docs.robin.io. And lastly, you can join our Slack channel. If you have any questions, we do have Kubernetes storage experts that can help you, set up your environments in the correct way and get you started on your journey to run stateful applications on Anthos. With that, thank you, Andrew. Thank you, everyone. Back to you, Andrew.
Fantastic. Thank you so much, Ankur. That was a great presentation. Now, I guess we'd love to hear from you, our customers. So please do reach out. We'll provide some links and contact details in the follow-up email where you can reach out and trial Robin and a combination of Anthos together. It'd be great to run one of those discovery workshops to help evaluate your current state too. So once again, thank you so much to Ankur and team, and we'll chat to you all very soon.